Okay, so this is section 5.3. Let's hope this video works this time. And it's about exponential functions. Now, before we get into the actual exponential functions, we just need to review a few of the laws of exponents. For instance, if you look at this first one, when you're multiplying two exponents together, just remember that you really add. Okay, and then when you raise an exponent to another exponent, you actually multiply. And then if you have two things joined, raised to the same exponent, make sure it gets distributed. The next one is 1 to any power, doesn't matter what it is always 1. And then the one that we're going to use quite often is this one here. So if you have a negative exponent, make sure you put it down in the denominator, or if it's in the denominator, make sure you move it up to the numerator. Okay, and then the last one over, anything to the 0 power is always 1. Okay, just a couple quick examples here if you look. So if I look at number 1, that's the first rule up there, so I'm actually going to add the exponent, so I get x to the first. Okay, next one over, I'm actually going to multiply the exponent, so I get x to the 10th. All right, then we keep on going. Here's the distributing one, x cubed, y cubed. Okay, so we're going to use a lot of those rules kind of mixed in with a lot of the other problems. Okay, so now let's take a look at the actual part of this lesson. Exponential function is a function of the form f of x is a to the x, where a is a positive real number. Okay, so the base a has to be positive. That's important. Okay, and then a can also not be 1, because if it were 1, the answers to everything would be 1, anything to the first power. Okay, and domain is a set of all real numbers. Okay, so let's take a look at a couple graphs, just so we can get going before we do the problems. If I look at number 1, 2 to the x, all right, the best way to start these is to plug in a couple points until you get the hang of them, until you remember how the rules work. So, first of all, anything to the 0 power is 1. So 2 to the 0 is 1. So the first point on here is always going to be 0, 1. Unless, of course, I start shifting, and we'll do that later. Okay, so 2 to the first is 2. And then try to give me a negative number, too, so you can kind of go in the negative direction. So 2 to the negative 1 would be 1 over 2, which is like a half. Okay, so if I keep going like that, I get this exponential function where it's kind of level, and then all of a sudden it shoots up to infinity. So remember, exponential means 2 cubed, 2 to the 4th, 2 to the 5th. You can see those numbers get big really fast. Okay, and then another important thing about exponential functions is they have a horizontal asymptote. So this one is going to be at 0. So if you think about it, if you raise something to an exponent, there's no way that number could ever equal 0. All right, and then another thing is if you raise a number to an exponent, you're not going to have any negatives. So if I start asking you for domain and range and asymptote, which I will, you do something like this. Domain, first of all, for all exponential functions, it's negative infinity to infinity. That's not going to change. Okay, the range is a thing that could change. For this one, where we haven't shifted or done anything crazy, range is just 0 to infinity. Okay, and then there's an HA, horizontal asymptote, at y equals 0. So I'll ask you for these 3 pieces of information for almost every graph that we do. Okay, let's do another one. Let's do one with a half. Okay, so if I look at number 2, all right. So anything to the 0 is 1. Let's start there. So 0, 1. If I plug in 1, a half to the first power is a half. And now let's go to the negative way. A half to the negative 1 actually goes up to 2. So if you look at this exponential function, it's actually decreasing. Right? It goes the opposite direction. All right, and then if we had to label everything again, it's going to have a horizontal asymptote at y equals 0. Domain, all real numbers, doesn't change. Range, 0 to infinity. HA at y equals 0. Now, careful with this. Make sure you say y equals 0. Don't just write 0, because sometimes in the next couple sections, we're going to have an x equals 0. Okay, so HA at y equals 0. All right, so we have a couple of the basic graphs down. Now let's do some shifting. Let's review this, because we haven't done this in a little bit. If I look at number 3, all right, 2 to the negative x minus 3. First, remember, the negative x means over the y-axis. And then the minus 3 at the end means down 3. Okay, so now what I'm going to do is I'm going to look at number 1, because I already have the base graph in my head. I've got it right there, number 1. And I'm going to first take all those points on number 1 and go over the y-axis. So if I do that, the point that's on the y-axis, 0, 1, doesn't change. Now the point that was originally at 1, 2 is now going to go to negative 1, 2. All right, and then the one at negative 1, 1/2 is at 1, 1/2. Okay, so here is 2 to the negative x. Okay, now picture the horizontal asymptote. I'm not going to draw it in, only because if I do, it starts getting a little bit messy. Okay, so now here's 2 to the negative x. Now I'm going to move all of those points down 3. So now I'm going to start doing some green here. So take the first point at 1, down 3. Take this point up that's up at 2, down 3. Okay, and the one that's 1/2, down 3. Okay, now let's draw on the horizontal before we sketch this graph, because we want to make sure we don't cross over it. So if it was originally at y = 0, that's where it originally was, I didn't draw it in, and I move it down 3, it now should be hanging out here at negative 3. Okay, so y = -3 would be my horizontal. All right, so now I can sketch it in and make sure it kind of levels out at negative 3. All right, let's go through the rules. Domain, all real numbers. That will not change. Range, okay, now think about it. I moved it down to negative 3. So now it should be negative 3 to infinity. All right, and then the HA, y = -3. Don't forget y =, don't just write negative 3. Okay, so now give number 4 a shot, try to compare it to number 2, and then we'll go over it in class tomorrow. All right, now let's talk about this base E. Students always get a little freaked out about base E, but don't worry too much. All I want you to remember, to start with until we really get the hang of these, is that E, first of all, it occurs in nature. That's why I call it natural log of E. E is about 2.72. Okay, so if you just keep remembering that E is smaller than 3, bigger than 2, it's somewhere in between those two numbers. So when we go to graph it, we're going to sketch it just like we did those first few examples where it was 2 to the x. Just think of it as 2 to the x. Same idea. Okay, so if I have to graph e to the x, okay, let's start. So first of all, anything to the 0 is 1. Okay, so that same point holds true. Okay, now, first power. If I said what's e to the first, you should say e. But if you're thinking about numbers, if you had to put this on a quiz or test and on my pieces of graph paper, e is going to be between 2 and 3. So if you just kind of sneak a little e on the quiz like that, then you graph the point 1e like this. Okay? And then think about the point of negative 1. If you had to graph 1 over e, it'd be 1 over 2 point something. So 1 over 2 point something is about here-ish. Okay, so now, if you look at this one, it looks very similar to the 2 to the x and 3 to the x and all those other base graphs with the same horizontal. Okay, so now we have to answer the quiz questions. We go, okay, domain is all real numbers. Range is 0 to infinity. HA, y = 0. All right, so don't get so scared when you see an E on something. Just think it's between 2 and 3 so I can treat it the same way I would a 2. All right, now on to the kind of algebraic side. So there's a graphical side of this lesson, and then there's an algebraic side of this lesson. Now, first news, all of these problems in this first section would be no calculator. Okay, so don't grab your calculator, don't start crunching out numbers. And what that means is you're going to have some of these facts in your head. So for instance, if you look at these little examples I have, if I said 3 cubed, you should probably be able to spout out 27 pretty quickly. And 2 to the 4th is 16, 2 to the 5th is 32. I might take you up to like 6 cubed, which is 216. So just kind of, you're going to have to study some of those facts so these go a little quickly. Okay, so I'm not going to touch a calculator on any of these. And the trick is to get the same base on both sides. And if you can do that, then you're home free. Okay, so for instance, look at number 1. I have a base 3 on the left and a base 81 on the right. So you should be thinking that 3 and 81 are somehow tied to each other. Well, 81 is 3 to the 4th. And again, if you don't hear that right away in your head, that's okay, but that's something you might want to start practicing. Okay, so if I can get the same base on both sides, take a look. Now I have 3 to the x plus 1 equals 3 to the 4th. What that means is that I can drop the bases at this point, because they're the same, and then I can just write the exponents must equal each other. So then I get x equals -3. So again, if you can get the same base on both sides, then you're good to go. Okay, let's try another one. Let's try the 81 thing again. So I have 3 to the negative x equals 3 to the 4th. All right, I've got it all set, same base. Drop the base. I get x equals negative 4. Okay, now the same holds true for number 3 when you get fractional exponents. If you can consider that 1 over 64 is really a 4th cubed, then you can compare it to a 4th to the x. So now look what happens. When I drop the bases on this one, all I get is x equals 3. Nice and easy. Okay, now they do get a little more complicated if you look at 4, 5, and 6 here. All right, so now let's consider the negative exponent thing. 1 over 5 is really 5 to the negative 1. So if I rewrite it like that, look what I have here. Then we can go in, slash, slash, x plus 3 equals negative 1. And we can get our answer, negative 4. Okay? Okay, now probably the most complicated two are like 5 and 6. All right, so I know that 4 and 2 are related, base 4, base 2. And I know that 4 is 2 squared. So that's a good place to start. But then don't forget, it's really 4 to the x squared. So what that means is it's 2 squared to the x squared. Okay? Now, remember the property. If I have an exponent raised to an exponent like this, I multiply them. So now I have 2 to the 2x squared equals 2 to the x. Okay, now when I drop the bases, now I have an x squared problem. Okay, now don't start dividing by x. Remember all your rules about x squareds. I'm going to have to factor this. Okay, so when you look at number 5, make sure, don't just divide by x. Make sure you move the x over. So if I do that, move the x over, and then start all your factoring. Okay, so if I do that, then I should get 2 answers for these. Okay. And these you can always check, so if you have a lot of time on a quiz or test, take those guys and plug them back in, see what happens. Okay, last one. All right, here's the most complicated, and you'll have a chance to practice this in the homework. You've got 3 base e's here. Okay, first let's use the rules. If I have an exponent to an exponent, I'm going to multiply them. So I get e to the 4x, e to the x squared equals e to the 12th. Now, you can't drop the bases yet, even though it looks like you have all base e's. You need to have a single e on the left equals a single e on the right. So I now need to combine these bases. Okay, now remember the rules of exponents. If I have something like this on the left, I'm really going to add the exponents. So here's what it's going to look like. All right, now I have a single e on the left and a single e on the right. So now I can go in and start dropping the bases and just writing the exponents. So now I'm going to write 4x plus x squared equals 12. Okay, so here's that x squared again. So now we should think factoring. So I'm going to rearrange a bit. There we go. And then I'm going to speed through this part because you guys can factor. I know that. And I get 2 answers again. All right, there's one more example. Here's a backwards one. I'm going to leave this for you to try. I want to see how many of you can go backwards. So here's the graph of an exponential. I want you to tell me what its equation is. All right, give it a shot and we'll go over it tomorrow.